Hi guys, today we're going to learn about the law of cosines. And as you can see from our first slide, the law of cosines is a way to determine angles and sides for obtuse triangles and acute triangles. Now in our previous unit, we used sine, cosine, and tangent to calculate angles and sides of right triangles. SOHCAHTOA is a great memory device, a mnemonic device, to help us remember the relationship among sine, cosine, tangent as detailed below. And for most of us, we are triggered by the word hypotenuse to remember that that is the side opposite the right angle, so it would have to be a right triangle. And there's the SOHCAHTOA relationship there for you. Now, what do we do, though, to calculate angles and sides when the triangle is not a right triangle? Since SOHCAHTOA is dependent on right triangles, we must use a different method. Our answer is we can use the law of cosines to calculate angles and sides for acute and obtuse triangles. Now, below are examples of acute triangles. And as you can see, an acute triangle is a triangle with three acute angles. And the acute angles are going to be less than 90 degrees, but greater than 0 degrees. And for those two triangles there on the screen, you can see that the three angles add up to 180 degrees. The sum of all three internal angles in any triangle is always 180 degrees. And below are examples of obtuse triangles. And as you can see, and as you probably already know, an obtuse triangle is a triangle with one obtuse angle, which means that angle is greater than 90 degrees, but less than 180 degrees, and two acute angles. As you can see, and as you probably already know, you cannot have two obtuse angles in one triangle, because a triangle, the sum of the three internal angles in a triangle is 180 exactly, and there's absolutely no way you could have two obtuse angles in one triangle. Mathematically, it is impossible. Now, the law of cosines is used to calculate the following. It's used to calculate the third side of a triangle when we know two sides of the triangle and the angle between them, and is also used to determine and calculate the angle of a triangle when we know the lengths of the three sides of the triangle. And we're going to get into the equation of the law of cosines right now. Now, the law of cosines, as you can see, is, in this situation, c squared is equal to a squared plus b squared minus 2ab times cosine of c. Now, this should be, it is a capital C, but it's hard to recognize that's a capital C, that's capital A, capital B, and it's important to note the differences between the lowercase abc and the uppercase abc. The lowercase abc represent the sides of a triangle opposite the uppercase A, B, and C, which represent the corresponding angles. That's critical. Remember, the lowercase A, B, and C represent the sides of the triangle that are opposite the uppercase A, B, C, which represent the corresponding angles. So here's, again, the law of cosines, which is c squared is equal to a squared plus b squared. Now, these are all lowercase, the c, the a, the b, minus 2ab, again, lowercase, times the cosine of uppercase C. Now because that would be angle, uppercase C is the angle, it resembles the Pythagorean theorem of c squared is equal to a squared plus b squared. If C is a right angle, then we get the Pythagorean theorem because the cosine of 90 degrees is 0. And as you can see, we plug in cosine of 90, that would be 0. If we do the calculations, anything times 0 is 0. So that would be c squared is equal to a squared plus b squared, proving that the law of cosines is identical to the Pythagorean theorem if the angle that we're looking at is 90 degrees. As a result, the law of cosines is typically used for acute and obtuse triangles, but not for right triangles. For right triangles, you would typically use SOHCAHTOA, you'd use the Pythagorean theorem. You most likely would not use the law of cosines. Mathematically, you could use it, but it's much easier not to use it. Now, very, very important, before you start your calculations, make sure your calculator is in degree mode. For our T84 Plus calculators that we have here in class, we got to press that mode key towards the upper half of your calculator, use your arrow keys to highlight degree, and then press the enter key to ensure that you're on degree mode. It's important to note that the default for our T84 Plus calculators is radian mode. So we must always check the setting and make sure we're on degree mode before we begin the law of cosine questions. If we're not in the degree mode, all our calculations will be wrong. So make sure we're in degree mode, and of course you can always check it by just hitting the mode key and making sure that you're in degree mode. Example 1 for the law of cosines. Now in the below triangle, side AB is 100. There it is. Side BC is going to be 66. And angle ABC is 25 degrees. What is the measurement of side AC? Well, we use our law of cosines. C squared, which is going to be the side, because it's lowercase, is equal to A squared plus B squared minus 2AB cosine of capital C. Capital C is going to be this guy, because capital C is the angle. Now, it doesn't matter what A and B is. One of these is going to be A, one of these is B, but you must be consistent. So in this case, I said A is equal to 100, and we used it here, and we used it here, and B is 66. We used it there and there. Again, you must be consistent. If you're going to have this be A, it has to be A throughout the equation. If this is B, it must be that throughout the equation. We do our calculations. The cosine of 25 degrees is going to be this, multiplying it all through, and then doing 14,356 minus this other piece, we get 2,392.84, square root both sides. We get side C is equal to 48.92. So side C is going to be, this side right here is 48.92. It's basically corresponds to this angle right here. Moving on, example 2. In the below diagram, side KM is 38 inches, side MN is 40 inches, and angle KMN is 93 degrees. What is the measurement of side KN, which is also denoted by lowercase m? Well, we'd use our law of cosines equation again. C squared is equal to A squared plus B squared. These are all lowercase because they are sides. Minus 2AB, those are lowercase because they're sides, times cosine of C, uppercase because it's an angle. What we're going to do is we're trying to figure out the side that corresponds to that angle, so it's lowercase c. C squared is equal to, now A and B, lowercase a and B, you just have to be consistent. So we're using, this is our A throughout, and this is our B throughout. There is our A, there's our A, there's our B, there's our B. We plug it into the equation, and we get C squared is equal to 3,203.1. Square root, we get this. C is equal, lowercase c is 56.6 inches. Now, students sometimes get confused. They're like, wait, this is a lowercase m, this is uppercase m. That's fine, because in our equation, that's uppercase c, that's lowercase c. They correspond to each other in the equation, and they correspond to each other in this drawing, but m, capital M, was the angle, lowercase m was the side. We use capital C for the angle and lowercase c for this side. So just be consistent. You'll see lowercase is side, uppercase is angle. Checking our work. Does our answers, do they even make sense from the previous question? Well, let's take a look. We can see that 93 degrees would be the largest angle in this obtuse triangle. We know that because a triangle, the three angles in a triangle, the sum of the three internal have to add up. The sum is 180 degrees. There is no way we can have another obtuse angle in this triangle. Therefore, this has to be the largest angle, and this would be the largest side because they correspond to each other. Now, this would be the smallest side. Therefore, that would, angle N right there would have to be the smallest angle. And this is the mid-level, right in the middle, kind of on the smaller side, but it's in the middle side, and this would be the middle angle. So that angle right there, angle K, would be smaller than angle M, but larger than angle N. And you can see, since angle KMN is the largest angle in this triangle, the corresponding side, lowercase m, must be the largest side, which it is. As a result, our answer makes sense. And it's very important to remember, the largest side in a triangle is always opposite the largest angle, and the shortest side is always opposite the smallest angle. Example 3. Given the below triangle, side AB is 3, side BC is 4, and side AC is 2, what is the measurement of ABC? ABC, now this is going to be the smallest angle because it's opposite the smallest side. We know here C is going to be used with 2. 2 is going to be lowercase c because we're trying to figure out what uppercase C is, the corresponding angle, which is right here. Now, it doesn't matter what A and B are, lowercase a and b, as long as you're consistent. There's our A, and there's our B, and we're consistent throughout all our A's and B's, lowercase, within this equation. We do our math, and we get the inverse of this fraction gives you 28.96 degrees. It's capital C because it's the angle. It's angle ABC, and it's 28.96 degrees. Now we continue working with that triangle from example 3, and we calculated that angle ABC was 28.96 degrees. What is a measure of angle BAC? Well, wait a second. This guy would be opposite the largest side. It's got to be the largest angle. That's what our mathematical rules state. Is it? Well, C, it's going to be lowercase, so it's the side 4 squared. It doesn't matter what A and B are as long as you're consistent. We said A is going to be 3 throughout the equation, and B is going to be 2. Those are lowercase a and b's. And C is what we're trying to figure out, which is capitalized, which is going to be this guy right here for angle BAC. We do our math, we do the inverse of this, and we get C, capital C, which is the angle, is 104.48 degrees. So we know that this guy is 104.48 degrees, angle BAC. Excuse me. We'll continue with the triangle from the previous example, and there it is. And we calculate angle ABC is 28.96 degrees because it's opposite the smallest side, so it's the smallest angle. And we calculated angle BAC is going to be the largest angle at 104.48 degrees because it's opposite the largest side. Since there are 180 degrees in every triangle, we can calculate the last angle, angle ACB, by simply doing 180 minus these other guys, these other two, to get you 46.56 degrees. And it makes sense because this is going to be the middle side and this is going to be the middle angle. It's not the largest and not the smallest. The smallest was this angle, which was opposite the smallest side, and the largest angle was this, opposite the largest side. Checking our work, we can do so quite easily, and we can see since side BC is the largest side, its corresponding angle, BAC, should be the largest angle, and it was, and it is. Since side AB is the middle value, its corresponding angle, BCA, should be smaller than angle BAC, but larger than angle ABC, which it is. And lastly, since AC is the smallest side, its corresponding angle, ABC, should be the smallest angle, and it is. And there are results, and they add up to 180 degrees. Now, tomorrow in class, we're going to review the following 2 questions in detail. Please do your best to complete these problems prior to arriving in class. Now, problem 1, you can see in the below triangle, side AB is 42, side AC is 21, and angle BAC is 39 degrees. What is the length of side BC? Remember, side lengths are going to be lowercase letters. Hint, hint. And don't forget that the angles are always going to be uppercase. Problem 2, in the below triangle, side AB is 7, side BC is 8, and side AC is 6. What is the measurement of angle CAB? You're looking for this. And hint, it's opposite the largest side, which means it should be most likely and definitively the largest angle in that triangle. I will also email you guys these slides so you can look through them on your own time as well. And I'm looking forward to seeing you guys in class tomorrow and working on these 2 problems in detail. Take care, guys.